You're welcome to solve this nice exponential problem, which is 9 to power x minus 3 to power x. This is equal to 12. So what is the value of x? Now, let's prevent the solution here. So from what we have here, we can express 9 to power x as 3 to power 2 raised to power x, subtract 3 to power x. This is equal to 12. Now, the next step from here, 3 to power 2 raised to power x, this is in the form of a to power n raised to power m, which we can express as a to power m raised to power n. So let's apply this exponent property so that now we'll have here 3 raised to power x raised to power 2, subtract 3 to power x, this is equal to 12. The next step is that let's say that let 3 to power x be equal to m. So let's substitute here. We'll have m squared minus m. This is equal to 12. So let's take 12 on the left hand side so that here we have m to power 2 minus m minus 12. This is equal to 0. So this is a quadratic equation of the form am squared plus bm plus c. This is equal to 0. So from this quadratic equation, we have a equal to 1, b equal to minus 1, and c equal to negative 12. So essentially here, we can apply the factorization method. We can apply the factorization method where we have the product as minus 12 and the sum here is equal to minus 1. So let's get these factors. We can get the factors, that is, we can have minus 4 and 3. These are actually the two factors. So here we'll have m squared minus 4m plus 3m subtract 12. This is equal to 0. Now from this part here, we can factor m here so that we'll have m into the bracket here, m minus 4, then plus. Now 3m and 12 here, you find that 3 is common here, so we factor out 3. So this is m minus 4. This is equal to 0. So this implies that here we have m plus 3 and we have m minus 4. This is equal to 0. So essentially here we have m plus 3. This is equal to 0 as the first part. Then we have m minus 4. This is equal to 0 as the second part. So this implies that m1 is equal to minus 3. And here m2 is equal to, that is plus 4. So we have m1 and m2. Now, if you recall, we are saying that let m be equal to 3 to power x. So let's substitute the first value of m here, which is minus 3. So we have 3 to power x. This is equal to negative 3. Now to solve for the value of x, we introduce logarithm on both sides. So this is the same thing as log 3 to power x. This is equal to log minus 3. But you find that the logarithm of a negative value here, this is actually undefined. So this approach will not give us the value of x. So now this part is rejected. So this part is rejected. That is m equal to minus 3. And this implies that we only have m2, which is equal to 4. Now, since we have m2 equal to 4, then now we'll have 3 to power x, this is equal to 4. So to solve for the value of x, we introduce logarithm on both sides. So this is log 3 to power x. This is equal to log 4. Now you find that log 3 to power x, this is in the form of log a to power n, which you can express as n log a. So applying this power rule property, then log 3 to power x becomes, this is the same thing as x log 3. This is equal to log 4. So let's divide both sides here by log 3 by log 3. So that now x will be equal to log 4 divided by log 3. So log 4 divided by log 3, this is in the form of log a divided by log b, which we can express as log a to base b. So applying this logarithm property, then we'll have the value of x equal to, this is the same thing as log 4 to base 3. So this is the value of x. So this is the value of x. So let's verify that this value of x actually satisfies the equation. So let's verify. Now, if you recall here, we end at 9 to power x, subtract 3 to power x. This is supposed to give us a value of 12. So let's substitute the value of x. So this is the same thing as 9 to power log 4 to base 3, subtract 3 raised to power log 4 to base 3. This is supposed to give us a value of 12. Now, from here, we can express 9 as 3 to power 2. So substituting this, we'll have 3 to power 2 multiplied by log 4 to base 3, subtract 3 to power log 4 to base 3. This is supposed to give us a value of 12. So this is 3 to power 2 log 4 to base 3. This is the power. We can express this as 3 to power log 4 to power 2 to base 3. Subtract 3 to power log 4 to base 3. This is supposed to give us a value of 12. Now, you find that 3 to power log 4 squared to base 3 and 3 to power log 4 to base 3. This is actually in the form of m to power log a to base m, and this is supposed to give us a value of a. So this implies that 3 to power log 4 to power 2 to base 3, this is the same thing as 4 squared, which is equal to 16. Okay? And then we have that 3 to power log 4 to base 3, this is actually equal to 4. Okay? So already we have this. We have 3 to power log 4 squared to base 3 equal to 16. And we have 3 to power log 4 to base 3 equal to 4. So this becomes a bit easy. So here we'll have 16 minus 4. This is supposed to give us a value of 12. Okay? So therefore, here we have 16 minus 4, and this is supposed to give us a value of 12. So 16 minus 4, this is 12, which is equal to 12. So the left hand side is equal to the right hand side. And therefore, this implies that the value of x, which is log 4 to base 3, actually satisfies the equation. So kindly follow the steps, like this video, and subscribe.